Avoid eye contact. Okay, so let's go through this and see where you're at. All right. So I really wanted you to get used to, rather than put the equation in your calculator and match it up to the graph, get used to what this is saying. You have a cube and it's positive. God bless you. It's going to cross 3 times. It's going to go down on the left, up on the right. That's what I want you to get from this. This went the opposite way. It went, oh, no, it didn't. It went down on the left, up on the right. And it crossed 1, 2, 3, 4, 5 times. So you're looking for something with a 5 and it to be positive. This is down. So you're looking for a negative square. This one appears the opposite way. Up on the left, down on the right. So there's a negative with a 3. This guy, what is this guy right here? Double root. It's bouncing off the x-axis. Normally, they come through the x-axis. A double root will bounce off. And that's where you usually get an x squared thing in there somewhere. Again, here's one that's as you're going down, and it's an even one. So you're looking for a negative and an even. There was your line. I don't know why they threw that in there, but that was okay. Here's a strange looking one. It's a 4 going up, positive. It's kind of hitting 1. It's kind of hard to see this. 1, 2, probably a double in here somewhere. Maybe it's an imaginary, I don't know. It's kind of hard on my graph. This is going up, even, positive. Please. Come on, Homer. No? Okay. Good. Okay. All right. That's what I want you to get out of that. And then these, I want you to get used to describing. Try to go with the flow here. Keep the same rhythm. 4, the highest exponent is 4. That's your highest degree. Your leading coefficient, positive. So it's the end behaviors, both are up. Left side up, right side up. These are your end behaviors. This guy, watch for the highest coefficient. That's this one. Highest coefficient. So the highest coefficient is a square, squaring function. Leading coefficient, sorry, the highest exponent is a square. Leading coefficient is negative. So your both sides are down. Down on the left, down on the right. This guy, you're still looking for the highest exponent. You're dividing it by a positive number, so all you care about is that it's positive. Positive to the 5, it's going down on the left, up on the right. The ends go in different directions. And this last one, if you just distribute this, your first term, your highest exponent, has a negative coefficient. So down on the left, down on the right. You're going to get 2 roots. I'm going to do these again today. 2 roots, 1 turn, no inflection. When these have this, you're going to get 5 roots, 4 turns, 3 inflections. So it's good. We've got a little pattern to go through. We're good? Just get used to describing. And then you had to go through a couple of these. Multiplicity is just the double root thing. If it has more than one, like if it's a double root, then it has a multiplicity factor of 2. We used it twice. So multiplicity is just anything that occurs more than once. Okay, so the first one. This one has 2 roots. X is equal to 5. X is equal to negative 5. Did either one repeat? Like, did it bounce off on either one? Nope, so a multiplicity of 1. Here we go. Here's a 3. When we took the square root, here's a 3. It's a plus or minus, and it bounces off. It just says double root, multiplicity of 2. Your double roots will be a multiplicity of 2. Everything else, there's no multiplicity. It's just another way the book named it. You'll see different names, just like in Algebra 2. You know, like when you took your Regents in or you went over Regents questions, they always like threw those different words at you, called it different ways. It does the same thing here. Are we okay with these? tell me. Can everybody sketch these? Trying to find the zeros. Double root here, so this tells me I have 3. I didn't ask you for an inflection point on these. This is probably the only one. 3 roots, 2 terms. We could see 2 terms. And this would have an inflection right here. I'd have an inflection point right here. But that means you have to find your minimum, your maximum, and you really didn't have to go that far for this. Just kind of get used to the feel of the curves. Good? And was that it? Is that, oh, one more. Okay. If you're finding the roots, that's when you can take out the 1/2 once you set it to 0. Just to find the roots, it doesn't matter what it is. To graph it, it does matter. But to find the roots, you can get rid of the 1/2. Be careful when, oh, this was already, we factored it out, but, and then we got rid of the 1/2. Complete the square. Complete the square, or you can use your quadratic formula if you wanted to. Complete the square is probably a little easier because it helps you get your turning point. That was probably one that had a little bit more work to it. So when you start describing, how many roots do you expect? 4 roots. What tells you 4? The highest exponent. 4 roots. How many turns? 3 turns. How many inflection points? Okay. Where are the ends behave? Where's my ends behaving? Up. Left up, right up. Okay. So now, let's see if we can figure this out. Let's look for our zeros. Set this equal to 0. This is the same as your x-intercept. Set y equal to 0. Everything that we do is algebraically except minimums and maximums. And then the inflection points we figure out by the midpoint. But minimums and maximums you generally can take off your calculators. But these I want everything else algebraically. So what can we factor out? X squared. And set these equal to 0. You can factor your perfect squares. You can add 25 and take the square root. Whatever you like to do. And this guy, what's that one give us? Double root. Good. So now, if we started to graph this, and we took our double root, here's our double root. We have a -5, we have a +5. Do you see symmetry? That means that your loops are going to be equal. So we got symmetry going on here. Now where do my end behaviors go? Up. So I know this is going up. I know this is going up. I know this has to come through because it's not a double root. And I know the middle guy has to bounce off. So what's this going to make? A W. So it's going to go like this. It's going to come down and go like this. Now graph it in your calculator and see if you get the same kind of graph. Remember, because you're doing a sketch, if in fact it ever comes real close or real far away, you're giving me a sketch. So it doesn't have to be like, don't crowd it all in there. Give yourself enough space to work. Generally, we like to label like points. If you label your roots, if you label your max and your mins, so that you don't, God bless you, so that you don't crowd everything right on there. Well, I'm glad you feel that. So did you put this in your graph? All right, so find me, what would D be called? Is D a minimum, maximum, minimum, relative, absolute? absolute. It shouldn't be an absolute. What would make it be a relative? If E was lower. So we do see symmetry. We knew the -5 and the 5. So we're really banking on that those two parts were the same. So find me your absolute minimum. Find me D and E. 3 decimal places.
I forgot to grab a calculator and just kind of spaced out.
Sorry. We all have those moments. Come on, don't be lazy. Chris, did you find D, Chris?
I was messing with the window so I could see the bottom one.
Yeah.
Okay.
Windows.
Yeah.
You have to put -2.
It's pretty far away, isn't it? It's pretty long. Well, try it this way. If you know this is between 0 and 5, why don't you just look at your table and look between 0 and 5 and see what's the point in the middle without messing with your window. Just go right to your table. Don't these both happen between 0, 5 and 0, -5? So if you look at your table and you just pull these first ones up, you should see the lowest point in your table. Rather than play with your window. Now could you just say, well, if it's in the -150, so I'll just make it -180, -200, whatever. Remember, we're a sketch. We're just a sketch. We had no idea where this was going. So somewhere halfway through there, D is -3.536 and -156.25. You're not seeing it? Oh wait, I want you to go to your table. Go to your table and look in your table. Oops. Ugh. Okay, so when you graph this, zoom 6 on this. Just get some kind of graph. Now, you see it's going between 0 and 5. Just look at your table. Watch. If I get to my table. Oh, hang on. Start your table at 0, incremented by 1. Go to your table, guys. Start at 0, incremented by 1. Look at this right here. From 0 to 5. From 0 to 5, that thing turns, doesn't it? I should be able to see it right here. And oddly, it looks like if these two are symmetric right in here, isn't it turning somewhere between 3 and 4? Shouldn't it be a little bit less than 144 because it didn't go like this, right? I get a curve. So I'll estimate it to be -200. All I want is a window to look at it. I don't want an exact value. So all I have to change now is my Y min. I'll make my Y min be -200. You're turning right between 0 and 5 and right between 0 and -5. Now when I graph this, if I can, I should be able to see it. I don't really care what's going on up there. All I care about is what's going on down here. I need to do a minimum on this. I could see my zeros in here. I can verify my zeros, 0, 5, and if I look up there, I'll see -5, right? That's a good way to verify. But right now, I just need to find the min. So do you see what I'm saying about your table? Somewhere right between 0 and 5, it's going to turn. Look at your table. Get used to setting your table sets back and forth and your windows back and forth. Could you do a minimum on these now? Right? Everybody's minimum's okay? Okay. All right, so now we've described this, and this guy, we know symmetry is here. It's still going to be now positive, and this guy is the same. This tells me absolute minimum. And I have symmetry. When I have symmetry through the y-axis, do I have an even function or an odd function? Even. So if I took this x and I put in here a negative x, it will be the exact same. So this tells me even function. I have an even function. Let's do increasing, decreasing. I start like from left to right. Do your thing here. Let's do domain and range first, if that's okay. What's your domain? All real numbers. What's your range? To positive infinity. Do I get a hard bracket or a soft bracket on 156.25? Hard bracket. Good. Okay, so now I know my domain and my range. I like to know my domain because when I do my increasing, all of my increasing, decreasing put together should make my whole domain. So here's my roller coaster. I'm decreasing, decreasing till I hit this x value. So I'm decreasing from negative infinity. Remember, my y is decreasing over an x interval. So I'm decreasing, decreasing until this x value. Then from here to here, from D to B, I'm increasing. So from this x value to this x value, I increased. And then what did I do from B to E? I decreased. So from 0 to 3.536, I decreased. And then from E on up, I increased. So this pretty much has to cover my whole domain, right? Good way to check. Here's an endpoint. Here's an endpoint. What do I see about those two pieces? Aren't those my minimum points in here? Okay. It kind of makes sense once you look at it. Yes.
Do you always have to do like soft brackets for increasing?
Increasing, decreasing, yeah, because it increases to a certain point, and really we don't stop at that point because it kind of shares it with the next thing that it goes to. So it shares that point. Now, let's find an inflection point. We said 4 roots, 3 turns. We see 3 turns, 2 inflection points. Here's my concave up. Here's another concave up. Do you see a concave down? In the middle, right? Here's my concave down. So if you do it this way, where you overlapped, right in here, between D and B, and between B and E, they overlap. So that's where I'm going to change my mind. I'm going to concave up, halfway through I'm going to change my mind. I'm going to concave down, halfway through, so I got to share. I'm going to change my mind and go back up again. These are my inflection points. So let's label this F and G. Now remember, a point has an xy value. So all we really have to do is find one x value. Shouldn't the other one be the symmetric part on the other side, right? And then as soon as I find one y, the y's are the same. Okay, so how do I find that x value? The x, do we say it again? Divided by 2. You're going to take the midpoint, right? The guy in the middle. How do I take the guy in the middle? It's the average. Take the average x from this guy. Not so bad. Take the average x from this, to the x from that guy, and take the average. So you're saying negative 3.536 plus 0 divided by 2. And this should give you negative 1.768. So my other side should be positive 1.768. Now, to find your y value, go to your calculator. Do this, second calc. Take a value. Put this in. This is close because we rounded, so we're not getting exactly, but we're going to be close enough. Calc, second calc, hit 1 for value. 768, is it? Okay, now, use that y value. Round it to 3 decimals, so negative 68.375. See it? That's giving me my y value. I don't have to do my average of my y. Sometimes it doesn't come out exactly the same. But I want the one that comes right on that graph. I want it to be on this graph. So just do second calc, 1 for value, put your x value in. This is also a good way to check your roots. If I say my roots are negative 5, my y should come out, God bless you, to say 0. Even when you have radicals, if you put your radical in there, your y should come out to say 0 if it's a root. So it's a good way to get used to that second calc thing. So that gives me my x value. And my x value was negative 68.375. Was it 375? Yeah. Thank you. Okay, so there's my inflection points. Now I could do my concavity. So my concave up and concave down. From left to right, are you making an upward in here? Right? It came down and came back up. I'm going to this point. I'm coming down, down, down to this point. Didn't I cave up? That's a concave up. So from negative infinity to this x value. And then what did I do between those two x values? What motion did I make? Down. I concave down. Between those two values. And then I changed my mind. There's my inflection point. I decided to concave back up. Back to infinity. I concaved up. Everybody get the concavity part? It's a little bit more difficult.
Oh, so you like, it's like increasing and decreasing, like you stop.
Inflection points, exactly. It has the same motion. You're coming from the left-hand side. You're just looking for an upward sweep. If you turn to go up, then you're a concave up. If you turn to go down, you're a concave down. Our inflection points are where we changed our mind. We were going to concave up here, but then we said, whoops, we got to change our mind, concave down. And an inflection point is the one in the middle. So think of when you find the number in the middle, you take the average. Okay? I think we got all the things we needed to find. Good with this? Questions at all?
There's like a question, that's what tell you everything to find.
Oh, I will list it all. Yeah, I will list them all for you, like I did the ABCD. Yeah, and it's easier for me as well, because when I have to go looking for all the parts, if you guys label them for me, I find them a little easier. That's why also labeling with letters here is so much easier, because if you think about it, if you put all these points on your graph, it just kind of takes up so much space, I can't even read them. I'm sure you can't either. So label it with points and set your points out over here. Sometimes if it helps you, put your x value there so you could see it, so then you know you're taking the average between them. I'm not saying don't write on your graph, just try to keep it as simple as possible. Good? Okay. Now, the next part. Before you panic about this, before you panic, hang on. I have a very basic quadratic. How do I find my roots to this very, very basic quadratic? Okay, so what would it say? -3, -2. So then you go like this. And so then you add 3 to the other side. I'm going to write the whole thing out. Add 2 to the other side. And these are your roots, right? So therefore, if I gave you the roots of this, and I said, find me the equation to this quadratic, because I only have 2 roots, so it's got to be an exponent of 2, right? So I say, work myself backwards. I start here. X is equal to 3. X is equal to 2. I'm working myself backwards. So then what was the next step I wanted to get? I wanted to set them. I'm working backwards, so I'm -3 this time. Instead of add 3, I'm -3, -2. So I'm x minus 3 equals 0. I'm x minus 2 equals 0. And then what did I do? I made them factors. Okay. And that's really my equation, right? If I want to FOIL it out, I would get back to this guy. Okay? So all I have to do is work myself backwards. What's another way that you learned when you're given 2 roots? Do you remember that little formula? Sum of the roots, product of the roots?
We didn't even study that.
Yep. The sum is -b over a, and the product is c over a. So if these are my roots, what's the sum of 3 plus 2? I thought I said the answer. I'm taking these. Give me the sum. These were formulas you probably learned last year.
No, I know, but
Yeah. Okay, watch. We're gonna get there. What's the sum of these 2 roots? 5. You're getting there. Okay, now I have 2 variables in one equation. I can't solve 2 variables in one equation. So I'm gonna say let a equal 1. Just get a out of there. We can worry about it later. So therefore, 5 is equal to -b. So what's b? -5. Now, product means multiply those. What's 2 times 3? 6. 6 is equal to c over a. Well, I let a equal 1, so what's c? So now, in my format, I say a is 1, b is -5, c is 6. Okay, if a is not 1, then b or c is going to come out like a fraction. And then when you do this, you're going to say this. You're going to say -1/2 x plus 3. Now, we never really see this with a fraction in it, right? So we're just going to multiply everybody by 2. So it always will work out for us because we're going to end up with a fraction as one of the other ones. And then we just multiply and get rid of our fraction. Okay? So we're going to keep this concept as we look at these. Everybody okay with this if I get rid of it? All right. Now, we also have a little bit of a nice thing going on here because we let you guys leave the roots rather than multiply them all out. Scissors just has to act up on me today. It's been good all the last couple days. So now, tell me how many roots we have to this. You see 4. 1, 2, 3, 4. So, what's my highest exponent going to be? 4. So somewhere I've got a polynomial in here, x to the 4th. These guys, not so bad. I'm going to set these 2 equal to 0. So x, I'm okay with x, right? X minus 2, oops. So far, let's start my equation. X times x minus 2. Good so far? Those I'm okay with. These guys give me a little bit of grief. What are those? Radicals, but what are those called? No? Conjugates. Those are conjugates. And where did they come from? They came from one equation that you either completed the square on, or you did quadratic formula on. So since these are a little more difficult for me to work with, I'm going to use my sum of the products and the sum and product of the roots. Now don't panic because this works out really, really nicely. Start like this. Now I want you in your calculator to do this. 4 in parentheses plus radical 5 plus 4 in parentheses minus radical 5. What's going to happen to the radical 5s when you add these? They're going to cancel out. Do it in your calculator. And what do you get? What's the sum? 8. So we say, well, I got 2 variables. I'm going to take out A, let A equal 1. Therefore, what's B going to be equal to? Negative 8. I got to solve for the positive B. Now, you have this in your calculator. Pull it back down. How do we take guess? Oh, we're going to worry about those in a second. We're going to worry about those in a second. So pull this back down, and now change this to a multiply. Aren't you going to take a product now? And when you take a product, these are your perfect squares. These are your conjugate pairs. Your middle terms disappear, either plus and minus, and your radical is going to be multiplied by itself. It's going to disappear. Just let your calculator do it. You did a sum, pull it down, do a product. What does your product become? So it becomes 16 minus 5, 11. Therefore, A is 1. What is C? 11. So if I did this quadratic, I would say x squared minus 8x plus 11. And both said, but wait, what about the other two? So now I have another little guy that I'm just going to add here. This is my function. Yes. Now, normally you see this all multiplied out because isn't x times x squared x to the 4th? Normally you get that whole long x to the 4th thing. But I don't really need to have you do that part. What you can do is you can put this in your calculator. You could go see if these are your roots. And this is what I was trying to explain to you before. If you go to your calculator, by the time I get this in, hopefully this will go in. If I put these all in, x, just like you read it, times okay, I'm just going to go back and do a zoom 6 so we get to a normal graph. I'm going to have something that should give me 4 roots. I could see 1, 2, and that's where your plus and minus is. If you zoomed in on that, you'd see 2 extra ones in there. And there's your 4. So I can find 0 in my table, and I can find 2 as a root. I've got 0 and 2. But now to find those, watch, just do this. Second calc, put one of those conjugates in. If one works, the other one has to work. Put it in. And now this y should come out and say what? 0. There's my root. So if one works, the other one has to. It's a conjugate. It either comes from your complete the square, where you take the square root, or it comes from your quadratic formula. Now you can leave it just like this. You don't have to multiply it out. I prefer you don't multiply it out because it gets you back to your original roots. This is something that's helpful when you have conjugate pairs. If you do this, watch, I don't want you to make this mistake. If you set these equal to x, they don't get multiplied by each other because this says x minus That's a factor. This says x minus this. Now, if you want, you can resolve this, and then you can multiply those two together, and you'll get your quadratic. But don't multiply just these two together because it's x minus x minus. So it's so much easier just to use your sum and product. Much easier.